All right, so sorry. uh, so this project was done on data visualization for manufacturing defects and recalls related to automotive manufacturers. And how can I use data analysis to come to an unbiased conclusion about the reliability and safety of a given car brand? A lot of information that's readily available for consumers is going to come from some sort of a biased media outlet or paid promotion. And this is an unbiased look at the reliability and recall information regarding cars. Um, I wanted to utilize technology to help consumers make a more informed decision when it comes to buying a car, but I've also had my own experience regarding a recall. I was driving one morning and my car just shut off while I was pulling out onto a 6-lane road. Uh, it was because of a recall that hadn't been issued yet, but that defect resulted in 124 deaths. Uh, the NHTSA is the government agency that regulates and monitors traffic safety. They handle all of the crash testing for cars in the US and they issue recalls. Recalls are when either a manufacturer or the NHTSA determine that there's a defect or the safety of a vehicle fails to meet certain safety standards. Another cause of recalls could be consumer complaints. I interpreted data from the US DOT and NHTSA, and I found the data set that included the information that I was looking for and interpreted that data set using Visual Studio Code and a Jupyter notebook. Then I displayed that information in the form of graphs on a dashboard that was created with Dash. Um, the data was collected by the NHTSA and includes all car recalls in the US from 1966 to today. The dataset was chosen based on the quality data metrics of validity, reliability, completeness, precision, integrity, and timelines. For validity, reliability, and integrity, getting the data from one of the government or from a government agency is going to be one of the better options. The data includes every recall from 1966 to now, so it's very complete and precise. The data set includes a link to information about each recall, the manufacturer, subject, component, recall type, number of affected vehicles, a description, consequence summary, and corrective action are listed for each recall, and it's all organized by date, so there's a timeline for all of it. The first thing I did was clean the data and remove the non-values, null values, anything that would cause an issue when graphing the data. The first thing I did was find the top 10 manufacturers with the most defects, and that's what's shown here. Then I went and graphed the top 20 manufacturers with the most recalls, and here's the output. As you can see, that's kind of a lot. It was really messy and hard to read. So I broke the data down into smaller groups uh, that were easier to read. I pulled out the most common manufacturers and picked 3 American manufacturers, 3 German manufacturers, 3 Japanese manufacturers, 6 economy manufacturers, and 6 luxury manufacturers. I graphed all of those in their own groups and then also compared by country of origin and luxury versus economy cars to see which groups had the most recalls. I also thought it would be interesting to see the most recalled component for each of the top 10 manufacturers, so I searched for that. Interestingly and concerningly, turns out the most recalled component is airbags, and that doesn't appear to be impacted by country of origin. Uh, the brands with the least number of recalls were Japanese brands, namely Honda, Nissan, and Toyota. German cars had more recalls than Japanese cars, but American cars had the most recalls. So if your primary concern when buying a car is the number of recalls, your best bet is to buy either a Honda or a Toyota. Here's a graph showing the country of origin for Japanese manufacturers, um, and then within the Japanese manufacturers, um, Toyota having the fewest. There's so many factors that go into choosing which car to buy, and this should only be used as a tool for helping make that decision. Looking only at the number of recalls in this data set is also somewhat misleading because there's no way to correct for overall number of cars being sold by a given brand. So something like an Aston Martin or a Bentley is going to have fewer recalls than a Honda Civic. There's also likely to be some sort of a bell curve with complaints and price, where a consumer may be willing to tolerate a small electrical problem on a Toyota, but that same issue would not be tolerated on a Mercedes. But then when you get into something like an Aston Martin, which may not be the owner's primary method of transportation, they may not be as critical. Because of these things, it's important to consider many factors when buying a car and find something that suits your needs. I would like to be able to explore how luxury sub-brands compare to their parent companies. Uh, the dataset combines recalls based on parent company, but it would be interesting to see how Lexus compares to Toyota or how Acura compares to Honda. Another thing that I'd like to have been able to do is to control for overall vehicles sold for each brand. That way I'm not directly comparing a brand that sells millions of vehicles per year with one that sells 10,000. And then, um, and here's my project. Um, so the first portion is just importing the libraries. And this is reading the CSV. This is dropping the null values from the CSV. This is isolating the manufacturer column. Here are the top 20 manufacturers with the most recalls, along with the number of recalls. Here's the top 20 most recalled components. Um, as you can see, airbags is pretty high up there. Um, I would probably disregard equipment because that's so vague. This is the top components for the top 10 manufacturers. So this is what was shown in the PowerPoint with airbags being at the top. Here's grouping the top manufacturers by country of origin, with Chrysler, General Motors, and Ford as American, BMW, Mercedes, and Volkswagen as German, and Honda, Nissan, and Toyota as Japanese. Here I was just trying to figure out how to isolate a specific manufacturer. So I just happened to choose BMW. So here's the graph from the slides with the top 20 manufacturers. That's just, there's no reading that. So then I went to top 10, which is still pretty hard to read. So that's when I went and separated by country of origin. So here's for American manufacturers with Ford, GM, and Chrysler. Here are the German manufacturers with Mercedes, Volkswagen, and BMW. And I have the number of recalls printed below the graphs. Here's the same thing for Japanese manufacturers with Honda, Toyota, and Nissan. This is where I compared by country of origin. As you can see, the Japanese manufacturers tended to have the least. Here's one I did for luxury manufacturers with Mercedes, Bentley, BMW, Jaguar, Volvo, and Aston Martin. Here's one that I did with economy manufacturers, Hyundai, Kia, Mitsubishi, Nissan, Volkswagen, and Mazda. And then here was comparing luxury and economy brands. The number of recalls was closer than I expected it to be. And then I made an ARIMA forecast for the predicted recalls from 2024 to 2027, or end of 2027. It does pretty much just turn into a straight line after 2025, but. And then here's the dashboard that I made. Here's just creating the dashboard, and here's the manufacturers that I have in the dashboard. And here's the groups that I made of manufacturers with luxury, economy, American, Japanese, German, and car class. And here's the layout for the dashboard itself with the different graphs that I used. And then here's callbacks for the graph. So I have a callback for top 10, American graph, German graph, Japanese graph, country of origin, luxury, economy, luxury versus economy, and the prediction chart. And then here's the dashboard itself. And the legends on these are selectable, so you can add and remove to make it easier to read. Here's the one for American manufacturers. Here's the one for German manufacturers. Here's the one for Japanese manufacturers. Here's the one for country of origin. And this one is a little bit hard to read, but having these selectable makes it easier. Here's the one for luxury manufacturers. Here's the one for economy manufacturers. There's a comparison between luxury and economy. And then here's the prediction chart. It I don't know why it's not scrolling down. Okay. You have to select them. But yeah, so there's the prediction chart. Like I said, this is more of a tool for making an informed decision. The data set doesn't control for overall number of vehicles sold or reliability of given models or brands and sub-brands. But if you're wanting to make a decision based on the number of recalls for a common car brand, then your best bet would be either a Honda or a Toyota. And that's my project.
Done? Okay.
Yes.
All right. Anyone have any question to Brock?
Brock, that was great presentation. What was the most challenging part of this project for you?
Coming up with the dashboard. I saw a lot of different things online about how to do it, and none of them seem to be working. And then I was able to settle on this one. But just getting somewhere to like visualize all of the graphs without somebody having to go step by step through VS Code.
Okay, interesting. Okay, and the other applications, so the data analysis part of those were those pretty straightforward to work with?
Yeah.
Some of those NumPy and all those.
Yeah.
Okay.
It was almost all stuff that we had done in the computer science program.
Okay. Great. Thank you.
Brooke, how do you get the data? Is it free or where do you get data? You
Yeah,
said
it
from
was.
NHS. You said NHTSA. Is it
Yeah,
free
it's
from them?
it's a government agency, and they publish the data. They just have a massive data set that was all recalls from January of 1966 until current. It's available online.
Thank you. It's very interesting. So I think we're done. So for next, let's go to the next. The next presenter, I think Kip. Kip, would you take the screen?
Yep, I will get there.
Yeah.
All right, so my project is Consolicom, a consolidated communication tool. And my thought behind this was there's a variety of forms of communications out there today, everything from email to social media, sharing calendars, web forums, video calls, telephone calls, texting, a ton of different ways to communicate out there. Accessing all these forms of communication can be a bit overwhelming, leading to task paralysis. For example, if you suffer from an affliction like ADHD, which a couple of my family members do, they get frustrated sometimes when they have to go to too many places to, look at email, communicate with friends or family members. If they have to check an email here, they have to log in somewhere and go there. Or if they want to check their social media, they have to log in and go somewhere else. And then my research throughout this, I couldn't find any easy to access non-business related portals that allow for a consolidation of a bunch of forms of communication. So my proposed solution is called Consolicom. It's an all-in-one communication portal that allows for simple, effective communication, calendar sharing, secure document sharing. This is a web-based solution that will have a login that will direct to a person's custom portal. This web application is developed in C# with SQL backend, and data is encrypted at rest as well as in transit using the AES 256 standard to go along with OWASP security guidelines. Also in the solution, the whole thing works on a friend circle based model, so where you can invite friends to join your circle, and that'll make for easy sharing of different documents you might want to share, or scheduling events together, or sharing social media feeds and clips and stuff like that. There's interactive real-time updating, and in the future it'll be highly customizable for keeping users engaged. So you'll be able to select different themes and different integrations. Some of the technologies I used while developing. Some open source things I used was Q Consultation Lite. This was for video chat and for chat functionality. Google Calendar for calendars. For greenfield development, the code base was stored in GitHub. I use C#, Microsoft SQL Server, and jQuery. So here's some of the data models I worked with. So the whole atomic unit is basically the user. And you can see there's basic information from the user, first name, last name, and then tied to that user will be an address. And then from there, we have such a metadata such as login info. This is just tracking how often a user log in, how many times they've logged in, just for like customer engagement. We have an event model, which is basically like a calendar event that can be added to your Google Calendar. Image for simple image sharing. So when this is deployed on a server, we'll follow a standard model of the way websites store things. So, an image would be stored in a location, and the location would be, there'd be a reference to the location in the database. So that would be the image table, and that's how we would go find the image. And then the future state would be a tracking information. So this would be something where you could, report your location, basically, and you could have your friends see where you're at. Here's a snapshot of part of the database. As you can see in this slide, that the main unit is the member ID. So, and then kind of from there, everything comes off of there. So you got your login info, the group assignment, your event table with, it has the main table that has your basic stuff, and then also has a customizable table off of that. You can have user custom items, and then the future state user tracking info table. My approach for developing this was using agile methodology. So, I kind of kept myself, I used a tracking board as I was kind of going through my work with Azure DevOps, an instance I had. So I made out my stories and my plans there. I didn't really have stand-ups or anything like that because it was just me. So I developed with the backend first. I used open source projects where available, and I used a continuous integration and development model in my Azure DevOps instance. So this will be like the main screen, the first screen that a user is presented with when they go to the portal. It's just a generic or pretty classic, login screen with email and password. We also have options for new account creation. If you forgot your password, we can do that. And then an unsuccessful login, prompts, the user to log in again. Here's an account creation screen. So normal login information, first name, last name, an email address, which will be the basis of the user ID. So it will be unique. Phone number, then you create your password. A new user when created is automatically an admin. So that's how we build this friend circle model. So this new user as an admin can invite friends. And then also you can select your social media integrations from here. Social media integrations take time to build programmatically and to kind of link to your social media accounts. So they are not presented upon first account creation. They take anywhere between 12 and 24 hours to fully generate. This is so in the main application itself, everything has its own card. So you have your email card, your calendar card, and then any social media integrations you would like to have. Here is a zoom in of the calendar card. So it's basically got a Google Calendar there, and we can easily add events with the Google Calendar. And as soon as the event is added, it will automatically update your calendar and be presented when the screen refreshes. Here is the close-up of the add event modal that pops up. Basically just enter some details and the event will be added to the calendar. Here's an example of the email card. So these emails, when you register, you'll select what email provider you have. And then basically we build a interaction with that email provider. Here I'm using Google because that's what I use for email. And then so basically what it'll do when you log in, all your new emails will be retrieved. And then you can also easily send emails from this portal. Clicking on any email will send you to your email provider of choice. So for example, if you're using Gmail, you click on the email and it would just take you to your classic Gmail screen, and you can read the full email or do whatever else you can classically do inside Gmail. Here's an example of a YouTube integration. So this, again, when the site loads, we go to your YouTube feed, basically pull out, your top 4 or top 5 videos, just so we don't have a whole long time loading. And then your YouTube feed will be presented in a scrollable format like this. And your YouTube video can either be watched either inside the portal itself within the card, or if you want to, you can go to YouTube and you can follow the link to YouTube and watch it. This is an example of an X integration. So again, same kind of thing where you have the card, so the whole feed is within that card. And then each X tweet is located in its own card. And if that tweet becomes too long, the card then becomes scrollable. So you have like a scroll within the scroll, basically. This is a TikTok card. Same kind of thing. It'll access upon login. You access your TikTok feed if you have one, if that's one of the integrations you chose. And again, your top 4 or 5 videos are showed just for loading purposes, speed of loading purposes. And then you can either watch the feed within the portal itself, or you can follow the link and watch on the TikTok native interface. Some future states I would like to see for this application is developing developing it for mobile platforms. Obviously, 10 weeks is not a whole lot of time to fully flesh out an idea and have it ready to go. But developing a mobile platform, I think, would make things a lot easier, especially for people with an affliction like ADHD, where things can become very difficult for them. We'd like to add features such as location sharing, a more variety of social media feeds that can be integrated. And also I have a plan to add like a chat-like feature. I wasn't able to do that with the time allowed, but a chat-like feature. And then I also need to add the document sharing and picture sharing. Anyway, so that is the presentation. Is there any questions up to this point, or I can go ahead and I can do a demo if you would like.
Yeah, you have minutes, you can go.
Okay. So this demo is just running on my local host. I didn't have a chance to deploy to an Azure instance or anything, so I'm just running it locally. So it might be a little bit slow. But so here you go, just a classic login. I won't go through the registration process. Like I said, because all the integrations don't happen right away, so I'll just use the one I've been using. So here we go with just a normal login here. And then right now, right behind the scenes right now, it's just gathering, your email information, your calendar, and your different feeds that you might have. So as you can see here, these are my newest emails that I haven't checked yet today. Obviously, most of them are junk because that's what we get nowadays is a whole bunch of junk emails. And then so here's my Google Calendar as it sits today. I'll go ahead and add an event here and see what we can do. So let's say I'm gonna have a graduation party at my house because hopefully I'm about to achieve my master's. So getting his master's in yes. So we're gonna say that's gonna be on the 23rd. We're gonna start that at 3:30, let's say. Actually, we'll go to the 23rd and we'll end it at like 8:30. So right now, I'm just going to add this to my calendar. And again, this just follows the kind of sharing your Google Calendar within your friend circle. So this would be, it would populate into all of your friends' Google Calendar. And you can see there it is added right there. So you can see, we just got, what the event is, where it's at, and then, kind of a brief description of that event. If we come down here a little bit farther, again, so here's kind of like the full view of the X feed that we have. So as you can see, these are just some of the latest tweets. I use something called Sociable to retrieve these X feeds, and they do not and Sociable does not update in real time. So that's why these tweets kind of are a little bit older. That's something I need to figure out how to do and web scrape on my own. The YouTube feed, on the other hand, was created by me by using the YouTube API. So as you can see, there's different videos here that are, my current, top ones in my YouTube account. And like I said, so if we want to go here and we want to, watch a video, we can start watching the video there, or we can go out to YouTube and watch it. And then finally, here would be an example of like a TikTok feed. Again, the same thing. These are just some of the latest ones I have, that are showing up right now. And again, we can either, watch it here online, or, we can go follow the link to TikTok to watch the full video in their native interface. Anyways, that's where the application sits as now. Does anybody have any questions at this time?
Yeah, great job. This is really amazing. Do you plan to maybe commercialize this thing? I could see a lot of people being interested potentially for this.
Yeah, I mean, that would be something I would like to do in the future. Ideally, we could get some kind of venture capital behind us, and I could build a team and stuff like that,
Right,
but,
yeah.
that's a pipe dream, but right now it's just me developing on my own. So, but yeah, I mean, I think I could see a lot of commercial applications for it, and it's just a matter of kind of, getting there at some point.
Okay. And how hard was it to integrate into some of the applications like X and Facebook and that kind of thing? How difficult was that?
I didn't get the chance to really explore Facebook too much. And like I said, for the X feed, I use something called Sociable, but
Okay.
that was a little bit cumbersome. I don't really like the way that worked. But the YouTube feed and the TikTok feed were pretty simple. It's just a matter of going and basically find, because every YouTube video and every TikTok video has the embed option in it. So it's just a matter of programmatically going in and finding that information and then building it in the website, through different calls. But you can get all the information, from different API calls, and that's how I did it. There was at one point a way to easily do that with X, but apparently that's been taken away. So I have to come up with a creative way to do that. So that's why I didn't do it with X at this point.
Oh, okay. Cool. Well, thank you.
Yep. Anything else? All right. Well, then I will stop sharing the screen, and I suppose we can move on to the next one. Thank you.
Thank you. It's beautiful. Thank you. So the last one is Hema. Hema, will you take the screen?
Yeah, sure. I'll share my screen right now. So can you guys see my screen?
Yes.
Okay. So this is my project, Secure Cloud Med Fortifying Data Privacy for the Electronic Health Records in Cloud Computing. So this project as a goal is to protect the privacy and individual health information. So, and also it protects the confidentiality and security of the healthcare data by enforcing standards. So these are the agendas, and I'll go with the problem statement first. So I'm using here with the HIPAA. The HIPAA stands for the Health Insurance Portability and Accountability Act. So it is actually an act that established the data privacy and the security requirements for the organizations. And also it increased the vulnerability of electronic health records, which is EHR, to the privacy breaches when migrated to the cloud computing. So it will actually emphasize the role of the third parties and also the potential for unauthorized access or maybe the exploitation by the hackers. And next is the motivation. So motivation is all about the cloud infrastructure's inheritance risk to the data privacy, especially EHR, which is electronic health records. The sensitive nature of this health records, it actually contains diagnosis, treatments, and personal patient information, and also mandates the highest security standards. So these are the motivations. And here's the background. So in this analyzing the pie chart, it actually represents the security breaches. So which is, there are three categories like security breaches, unauthorized access, and data privacy violations, and all the predominant concerns. The first one is the security breaches. So because this is the largest portion of this pie chart at 40%. So this actually suggests that security breaches are the primary concerns for the electronic health records, which is actually stored in the cloud computing systems. And the second one is unauthorized access. So this is the second largest concern at 30%, which is like unauthorized access will refers to the instances with the proper permissions. So this could be due to the weak access controls, or maybe like the insider threats or the external attacks that bypass the security measures. And third one is the data privacy violations. So this is like a 20%. The data privacy violation concerns about only the improper handling of the patient information that can lead to the privacy breach. So the 10%, this is a smaller slide. So it actually represents a collection of miscellaneous concerns and not specifically categorized. So these are the primary concerns. And here's the related work here. So in this graph, it actually represents the encryptional technologies like AES, RSA, and homomorphic encryption. So in AES, we actually have the effectiveness and computational overhead. So in this, in AES effectiveness, this bar is the tallest among the three for effectiveness, making it less effective. That AES can able to that AES is highly effective. So the exact percentage isn't visible, but it appears to be around 80% or above. So this is the RSA effectiveness, and RSA appears to be around 60 to 80, 70% effectively. So it actually making it less effective than AES, but it is reasonably strong. And the third one is homomorphic encryption. So this effectiveness bar is for the homomorphic is not fully visible, but it is slightly shorter than one for the AES, suggesting that it is slightly effective. So this is a related works. And here I go with the approach. This is a system architecture. So it is designed to manage access control and data storage. There are few components like data repository, healthcare institutions, lattice data stores, the depth sky, and the depth space. So these are the key components. So I'll go with the healthcare institution first. So they are actually responsible for collecting the patient data, so it can able to manage the electronic health records and also the facilitating day-to-day healthcare operations. And here we go with the depth sky. So this depth sky and the cloud storage. So our data is stored across these four these four cloud providers. So it actually creates a redundant system that will actually not ensure that data is never lost, but also it distributes the risk. So the impact of this potential cloud service outstages. So here we go with the lattice data store. The lattice data structure is used for the data classification and also the storage. This will actually optimize the organization and also the retrieval of a complex healthcare records. And here we have the depth space. So this depth space acts as an interface layer. So between the clouds services and also our healthcare institution systems. So it is responsible for managing the data synchronization. So this is a system architecture for this approach. And here we have the sequence diagram, and we have the three components, which is like healthcare system, lattice data store, and data repository. Here's the user here. And here we go with the healthcare system. So this component actually initiates the process by requesting the data such as a file or record through a method call. So it represents the user interface that where healthcare professionals interact with the systems. And there we go with the lattice data store. So after this initial request has done, so this component is query to retrieve the associated access control data or maybe the permissions, and also it actually manages the access control policies for the requested data. And at last we go with the data repository. This is the storage unit where actually files or maybe the patient records are kept inside. So once the permissions are verified from the lattice data store, the file is actually retrieved from here and sent it back to the healthcare system. So these are the sequences diagram. And here's the approach. This is all about the comparisons of the existing solutions and also the criteria. Here's the system existing controls that can able to integrate with the current systems and can do the security features and the limitations. So these are the approaches. So here's the design. This is my web page, and this is my user admin web page, and these are the Amazon AdDS. So I'm going to implement this with these frameworks like Django for its security, and AWS for reliable cloud storage, and AES encryption and CSRF protections. So this actually ensures the confidentiality. So these are the implementations I'm doing with. And here's is the data collections. So this is the secondary data source. That's why I'm getting the data collection from here. So it actually includes peer review articles like governments, publications, and industry reports. So this metrics actually measures the system performance and the scalability and also the data integrity, encryption efficiency. So these are the compliance with the privacy regulations and resistance to the security threats. And here's the data analysis. So these are the core advantages of the project's approach, with focusing on advanced analytical tools like encryption efficiency and comprehensive testings and validations. So, and these are the compliance standards. So we have the data analysis that out of the entire data set, we have a sample of 500 records using IBM SPSS tool. So in this statistical table, we have two variables. So from a data set of 500 patients, the patient ID variable actually, it shows like IDs ranking from 1242 to 4306. So which you can be able to the like average around 282. So in time, the variable, it ranges from 3 to exactly an entire day. So the average time recorded is about 12 hours. So, and yet the standard deviation is over 7 hours. This is the data analysis, statistics. And here we go with the data analysis, timestamps and medical records with the frequencies. So this histogram in these figures are the medical records across the time and patient demographics. So this actually represent the frequency of the sensitive activities. So on the other hand, the maps out of a landscape of a patient ID. So this has the blueprint for diving deeper, like adding layers of the complexity and colors by considering like the variables. And here's the findings. So the parameters, it has a 3 parameters like patient IDs, time stamps, and medical records. So the patient ID is nothing but it is a unique identifier for each patient in the system. So this is a crucial for linking the medical records. So here we have the timestamps. So these are used to record which they created or maybe like modifying or maybe accessing or any other significant event or maybe providing in chronological content. So these are the timestamps for the parameters. And the third one is medical records. So these are the core data elements of our system. So it actually contains the health related informations of the patients. And we have the security levels of the medical records, which is like sensitive, moderately sensitive, and extremely sensitive. So these are the categories. It is a record that how sensitive and how could be accessed by a broader range of healthcare staffs. And here's the critical aspects of the system. So these are the security protocols, like how data are sensitive. And here's the conclusion. So finally, it's all about innovation, security, and privacy lays. So how the groundwork for a safer or maybe more secure healthcare future. Here's the future work. So this is actually integrate the advanced cryptographic mechanisms like digital signatures and MD5 hashing for heightened data integrity and authentication. So this will actually develop the robust security protocols in cloud-based healthcare. And these are the key references. And I'll show you the video of the demo. So here is a healthcare appointment system, which is actually designed to enhance the patient's care, which actually strictly adhering to the HIPAA compliance. So this system is built on Django framework, renowned for its robust security features and efficient data management capabilities, particularly to the Django admin interface. So this is the login screen, and I'm going to explain this login initially. So in this, we can able to create 3 different user roles like patients, staffs, and also the doctors. So initially, I'm creating the account as a patient. So I'll explain it right here. So I'm doing it as a Alex and Whiteman. Here's a username, emails, and passwords. I'm creating an account. And again, I'm logging in with the same username and passwords. So here's a button called make an appointment, and we click it directly to make an appointment. So here's the details, and we are creating an appointment for this. So once we make an appointment successfully, so this data will be directly stored in Django admin page. So this is an admin page, Django. So Django is nothing but like authorization and authentication. So it is actually encrypted strongly, and security features added in this admin page, such as passwords or maybe very strongly encrypted algorithms. So it is based on the security features of HIPAA compliance. So we can see the roles and permissions here. And I'll explain the final page. This is my final page. So this is nothing but how the once the appointment is confirmed, so those details will be updated like the list of appointments. So this is the hospital system which is incorporated with the HIPAA compliance. So I'll explain the security features. I'll do the code. 1 second. So this is the middleware templates and the databases here. And I'm gonna explain the security features. So this is actually the encryption, SSL TLS encryption. So the data will be transmitted between the clients and the server, which can be protecting the sensitive information. And the secure cookies and CSRF tokens. In these cookies, this will actually send over HTTPS connection, enhancing the protection against the interceptions. And the third one is a session management. So if it is true, so it actually clears the session data when the user closes their browser. So it actually reduces the risk of unauthorized access. So the fourth one is XSS, cross-site scripting, XSS protection. So this will actually enable the browser mitigates that XSS attacks, which could lead to the unauthorized data access. And the fifth one is clickjacking the protection. So these are the protection X-frame options. So this will deny, it actually prevents the application from being embedded within the frames or on other sites, reducing the clickjacking risk. So these are the clickjacking protections. And the last one is content header protection. This actually prevents the browsers from mime sniffing responses. So it will actually reduce those certain attack vectors. So totally, this is the hospital system, which is incorporated by the HIPAA compliance. So this is it.
Wow, thank you so much. Very interesting. So, do you have any question? No questions. So thank you so much. Congratulations for the students. So we done the today's session. Thank you.
Thank you so much.
I think we done.